Oh, happy Tuesday. Today is May 3rd, and we are on our second day of our May number corner journey. And today, as you can see in the background, we are going to finally become acquainted, and I say finally, even though it's only been 2 days, right? Become acquainted with our calendar grid and what's happening. We know that the calendar grid has patterns. There's some really interesting things that happen from month to month. So I guess we have to find out what's happening this month. So let's take a look and see. Now, before we do, there are some vocabulary terms that I want to remind you of because I want you to utilize these terms as you are making observations about what's happening on these calendar grid markers. So let's review some terms. So there are some different types of angles. Maybe you'll look at something on the calendar grid marker and maybe you want to make an observation about the type of angle. Well, there are multiple types of angles. You have an acute angle. It's really cute and little. It's smaller than 90 degrees. Okay? And a 90-degree angle is a right angle, and we can really easily see a right angle or figure out if it's a right angle because it fits really nicely into a corner. Okay, that's 90 degrees. And so bigger than that would be an obtuse angle. If a triangle, so maybe that's a hint for you, if a triangle has an angle that's a right angle, which means an angle that's 90 degrees, then we call that a right triangle. Okay. We also say triangles are congruent if they are the same shape and the same size. Even if they look different, their orientation might look different, meaning maybe it's turned one way versus the other way. But if they're the same size, same shape, we would say that's congruent. So let's go ahead and take a look at our calendar grid for this month. We're going to start with May 1st so that we can see what's happening with the pattern for this month. Here we go. Day 1. And I'm going to make this bigger. Oopsie. Let me scroll up so you can see. Maybe move my beautiful face. What do you notice? You're right, it is a triangle. What else could I say about this triangle? Yeah, you see some acute angles. Here would be an acute angle, and here would be an acute angle. What other types of angles do you see? Oh, you're noticing what I said about fitting really good in a corner for a 90-degree angle. So here is my paper triangle. Here, I can show you as best as I possibly can. This corner right here makes a 90-degree angle because it fits right in the corner of this grid that's made here on this calendar marker. So we have a triangle. We see some acute angles. We also see a right angle. Let's look and see what yesterday's calendar marker looked like. What observations might you make about this triangle? Yeah, did somebody say it's also a right triangle? Remember when you have an angle on a triangle? That's a right angle, which means it's 90 degrees, perfectly fits right there in that corner. That's called a right triangle. You're right, it is a right triangle. What else can we say about it? Did I hear the words congruent? You're saying that this triangle is congruent to this triangle? You're absolutely right. They are congruent. And congruent means same shape, same size. And it looks like they are the same shape and same size. But there's something different about this one and this one. Yeah, it's turned maybe we can say turned. And we'll talk more about that in just a few moments. Let's look at today's calendar marker. Oh my gosh. Is that also a right triangle? Is it congruent? Uh-huh. You are absolutely right. It is. So let's take a closer look at these triangles and make some, let's prove some things, okay? So here's my triangle. Here's what it looks like on my very first calendar marker. And I'm going to verify that. Yes, it does. Okay, and we said it had a 90-degree angle, and you may have heard me say if it fits really good in a corner, that's one way that you can tell if it's 90 degrees. I like to use index cards as like a really definitive way. You could also use, what is that thing called that you measure angles with? Is that a protractor? You could, absolutely. And you guys have measured angles this year, I hope, maybe. I could put this right here, and maybe I need to turn it so that it's actually straight as best as I possibly can. Do y'all see that that's a 90-degree angle? Okay, now, when we looked at day 2, it looks the same. It's congruent. Well, it doesn't look the same. Same shape, yes. Same size, yes. Different orientation, yes. Wonder what happened. So, probably be easier if I show you here on my paper triangle. So this mimics what I'm seeing on my screen. I could fit this right on top of that triangle. But on day 2, it looks like this. Did you guys see what I did? Do you know what that's called? It's called a flip. I flipped it. Now, if I were to show you a flip on the screen, it would probably have to look like a rotation, a turn, right? Because it's really, I physically can't do it on the screen. That's why I'm showing you with my, my paper triangle here. So first it starts off like this, and then it flips, and it's like this. Or you saw that I turned it, and it's like, it looks the same. So then, can I turn it again? Or maybe flip it again, perhaps. So first I flipped it along the horizontal line. And then for day 3, and I am going back and forth, so hopefully you guys are keeping up with me. In day 3, it looks like I flipped it again along the vertical line. Do y'all see that? Let me start from the top. Here's day 1. Flip it on this imaginary horizontal line. Here's day 2. And then here's my imaginary, I guess I can use my finger as a vertical line, and I flipped it like this. Yeah, those are called flips. What you saw me do here is a rotation or a turn. So I'm turning it about 90 degrees each time. Now, let me just show you the first one again. Here's the first one. What would happen? What's this called if I just move it down here? I take it and I say, it's just a slide, right? It's just a slide. But it looks like day 1 we're here. Day 2 we turn 90 degrees. And then day 3 we turned 90 degrees. What can we make a prediction about what's going to happen with day 4? Maybe it's going to turn 90 degrees, so it would be here and 90 degrees. So then if I make 4 flips, so here's 1 from 2, 3. Am I back where I started? No, I have to make a 4th flip, which would be like this, or a rotation on my digital screen, to get where I left off. Do we think day 5 might be that? I guess we are going to have to wait and see. So, we made some observations. We've used some of our vocabulary terms. I've shown you what days 1, 2, and 3 look like, and we're not going to fill out our calendar grid recording sheet just yet. but that is here, and we could because we know what it's called. And we also, ooh, do y'all see this word here? Symmetry. Do you know what symmetry is? Let me show you that really quickly. I'm going to turn my triangle like this and put it here along this line. And that means, is this triangle symmetrical? Meaning, if I were to fold it in half, that it would be the exact same. And Miss Trammell did a really good job cutting this triangle out because, look, it is exactly the same. It's like a mirror image of the other side. So if that happens, we say it's symmetrical. There is a line of symmetry. And so when we start recording, we're going to have to take note of that. But right now, we're just making some observations, using some mathematical language, and we're going to come back to that very soon. But what we are going to do is look at our water experiment. Here is the photo for day 3, and I am going to make it bigger so you can see. My hands are on my hips, guys, in case you can't tell. My gosh, by the 3rd day, some of the water has evaporated. Do you, and I'm going to exit out, and I'm going to try to do something to make it even bigger so that maybe we get a better view of it. Do you recall me saying that we have to be very precise? We have to work on our precision. Yeah? So I know that it's less than 200 milliliters. So I'm going to have to use some of my reasoning skills. It's less than 200 milliliters, more than 175 milliliters. So that's 25 milliliters in between each of these marks on this measuring cup. And so half of 25 milliliters would be about 12 and a half. And I know it hasn't gone 12 and a half. 12 and a half would be right about where you see my cursor moving here. So it's hasn't quite gone or evaporated 12 and a half milliliters. So I might estimate and say that this is maybe 195 milliliters. Would that be a good estimate? Yeah, because it might have only evaporated about 5 milliliters, maybe even 6 or 7. So that was a lot, don't you think? Remember that question I asked you guys yesterday about, I wonder, would it evaporate at the same rate? So if this is the rate, I wonder when the water might be gone. I guess we'll have to wait and see. So we now have 0 days that have passed, 1 day that it's passed, now 2 days that have passed, and I should have copied this from the other from yesterday, but it's okay. And so we're going to estimate about 195, maybe 193 milliliters are currently in the measuring cup. So not that much water has evaporated, but pretty significant from yesterday. So I wonder what's going to happen next. Well, I guess we'll have to find out on day 3 of Number Corner, which is tomorrow. Thank you guys for joining me today, and I'll see you next time. Bye.